Hello and welcome to episode number 6 of Getting Started with Houdini, and in this one we will be taking a look at very important parts of Houdini, which is the Houdini engine that will allow us to create Houdini digital assets that we can use inside of other applications, in our case inside of Unreal Engine 5. So as you can see, I've already imported the digital asset that we will be creating in Houdini, and as you can see I can move around. There is this little icon of Houdini on top. That means that it indeed is digital asset, and as you can see it's a column. And of course the interesting part about this is that we can go and start tweaking our column. For example, we can change the radius of our main column, make it really thin like this. Or we can change the number of pillar elements, for whatever reason I call it column pillar, and it can be 12, 16, 32, pretty much any number you can put. And as you can see, everything rebuilds. We have automatic UVs and everything looking pretty good. So let's learn how to do just that. I just want to say that if you're interested in getting the asset files, consider subscribing to Patreon, or if you're not interested in subscriptions, you can get it from the Gumroad page or any other store. And without further ado, let's go back to Houdini and start creating our digital asset and learn how to procedurally model a column like this. As per usual, first let's save our project. Let's enable the autosave in case it crashes, and let's start creating. Of course, the first thing will be geometry. Enter, and let's start with a tube. So what we're gonna do is create this tube, make it much higher, obviously. And of course, first I wanna do is introduce you to the node that's called match size. So what match size does, it can procedurally place our geometry. For example, in this case, we will just justify the minimum to the 0, 0, 0 coordinates. As you can see, no matter how high our tube will be, again, actually let's do it like this. If I disable this, it just, it's centered and goes up and down. However, with the match size, of course, it places it on top of 0 coordinates and procedurally places it so it kind of looks, kind of correct, right? As it where it should be. Now, what we're gonna do next is create a group. And in this group, actually, not the group by range. So what group by range will allow us to do is select every second, as you can see, every second element of our pillar, so we can procedurally poly extrude it and use that as the basement for our pillar. Poly extrude, shift enter, everything looks fine. Now, if we go to individual elements, you will see that indeed we can do something like that. However, what we really want to do is get into the group, and as you can see, this group by range is called group 1. Of course, we can name it however we want, so let's say our selection. Just for the sake of the illustration, you can just skip the renaming, but so that we are clear for this tutorial, you'll see that indeed we can just select our selection, and of course it will extrude every second elements of our pillar. Of course, we can do slight inset, something like this. Tweak it a little bit, and there we go. So I think distance can be a little bit bigger. Anyway, so what I'm trying to say is that when we have procedurally selected 1 out of 2, and then we again procedurally selected in the poly extrusion group, if we now start to play with the amounts of columns in our column, you will see that indeed it automatically selects every second of those and starts to work with them as expected. So let's make 12, and of course let's poly bevel so that it's kind of it has smoother edges. All right, delete the group. I think the distance should be really small, And of course, we can do just a couple of divisions just to make it ever so slightly more roundish. Again, let's see how it works. And everything works perfectly. Great. So what next? Next would be another tube, of course, so that we can have the caps on top and on the bottom of our pillar. In this case, height can be really small. The radius, actually, let's do radius procedurally. So, to have the radius procedurally adjusted based on the radius of our tube, it's relatively simple to do. All you gotta do is go to our tube, that is the actual pillar itself, right-click on the radius scale, copy parameter, go to our cap of our column, erase this, place paste relative references by right-clicking, press enter. As you can see, if we change this now, our cap will adjust as well. However, we can add 0.1, for example, so it is a little bit wider. 0.1, actually, maybe 0.2. You'll see in a second what I'm trying to do. All right, so the radius scale is 1.2, and of course, if we make it 0.8 here, it will be 1 here. So basically, it's procedurally adjusting based on the radius of this. Next up, I will enable the end caps because that's what we need. And then another match size. Get it here. And the second input of our match size will be the geometry whose bounding box is to be matched. That's this one, the polybevel. Let's see. What we want to do is we want to justify the Y to the max. And as you can see, it's not enough, of course, and we should offset it a little bit, right? So how much should we offset it? The answer is by the height of our element. So for example, let's just, for the sake of the illustration, again, copy parameter, and here, delete everything, paste relative references, press enter, and if we now merge everything, you will see that indeed it works as expected. And if we change the height of our column, or indeed the radius of our column, you will see that everything works procedurally, and that's very good. However, that's not all that I want to do with this. Let's get back to our tube, which is the foundation of our pillar, or the top cap, however you want to look at it, and increase the number of columns. In this case, we can do whatever we want, like 36 or whatever. It doesn't really matter. Actually, the more the better, because we want it really round-ish when we are looking at it in the game. And we will decrease the height to something like 0.1. Let me explain. What we're going to do now is we will procedurally select the bottom face. To do that, we again get to the group, not group by range in this instance, just by group. And of course, if I enable the normals, what we will need is the face that looks downwards. That's relatively easy to do because all we need to do is enable keep by normals, press enable, and the direction of y-axis is up and down. So something that will look at the bottom will be in the negative y-axis. So x, y, -1, z, 0. Spread angle. Reduce the spread angle, as you can see, so it doesn't actually take into consideration any other face. And as you can see, we procedurally selected the bottom face. That will be really useful when we do another poly extrusion. Insert it, and it says group 1. Let's rename it to selected extrusion, so we will not be confused what we're doing. Maybe someone will get our HDA and it will be really hard to understand what's going on, but in our case. So we named it like maybe in the production or for ourselves, if we open up this HDA 1 year later and we would not remember what's going on. Anyway, so as you can see, this is the distance. I think the distance, something like this will do, 0.25 for example. And what I'm gonna do is create a little bit of a profile, and that is easily done if we go to this spline control. And there is the thickness ramp. I think by default, it looks kind of like this. So we open it up and start tweaking. As you can see, nothing is happening because we need to increase the number of divisions. I think let's do the 32, why not? All right, so here we are in our, whoops, come on. So that's, this is part when you can just do whatever you basically want. It doesn't really matter because we can adjust it when we look at the pillar itself. And in fact, let's see how it looks. I think we need to compress a little bit the bottom part because this doesn't look right. And of course, as you can see, since we have poly-extruded this, but our mesh size took into consideration only the height of this part, of this initial part, and it doesn't take into consideration the extrusion, we have to add the amount of justification offset, the initial height of the tube, this one, we have to add the poly-extrude amount. Again, right-click, copy parameter, go to our mesh size, and let's try plus, right-click, paste relative references, enter. And as you can see, no matter how far we extrude, it will be, let me enable the merge so we can see more clearly. No matter how far our poly extrusion will go, it will be automatically placed on top. Really useful. Let's say 0.25. All right, so I think now we can basically tweak it. I think the radius scale plus 0.3, maybe 0.4 will do. We go to back to our poly extrusion. Let's tweak the spline control a little bit more. Kind of like something like, I think something like this will do. Okay, that's nice. All right, so the last part I want to do is to basically have it on the bottom as well. So that'll be another mesh size, Control C, Control V. In this case, we have to rotate it 180 degrees. Again, let's do the transform. Here we go, rotate it, 180. Cool. And if I now place it in the mesh size, you will see it, whoops, actually we need to mesh size it to our column. As you can see, it again has been placed at the top. Of course, I forgot to enable the transformation. Anyway, what I'm trying to say is we need to justify not to the max, but to the minimum in this case. And we have to invert our offsets because it's now offset by 0.35. Again, this is the height of our initial tube plus height of our poly extrusion. So since we are doing it into the reverse, we need to actually say negative channel tube height minus channel poly extrusion, press enter, and voila, we have the result. And finally, we can just delete this connection, get it here, get it there. You'll see that we have our procedural column. All right, this is looking good. So what's next? The next somewhat tricky part will be to actually make it one geometry. As you can see, in fact, it now is kind of floating around. So if I press select, by 3D connected geometry, you will see that this whole thing is not a connected geometry, it's just 3 elements floating around, which happen to be relatively close to each other, right? If I select this, press transform, you'll see that it's not connected. That's not what we want. We need it made to be connected. How do we do that? We get it through the Boolean. So if you remember, the Boolean has not just this abstraction, but union as well. So we do the union, and what we need to do now is to union this thing with our 2 elements of our caps, 2 things. So I will deselect the merge, get the element A here and the element B here. So in this case, I think it worked rather well. However, sometimes it might be a little bit wonky, and in fact, you can fix the wonkiness if you tweak the mesh size just a little bit. For example, the top, remember, offset 0.35, let's say channel 1 plus channel 2, negative 0.01. As you can see, it ever so slightly moved downwards, right? So that it has a better connection for our Boolean unionization. And invert it, the negative 0.35, negative channel 1, negative channel 2, plus 0.01. It will move ever so slightly on top. Here we go. So if you had problems with your Boolean, now it will be working a little bit better. All right, so next up, what I want to do is, in the Boolean, there is a way to enable the AB seams. We do just that. And of course, whoops, we can polybevel, and we can select just the AB seams. As you can see, Procedural has selected the correct things. And now, let's do the round, super small distance, a couple of divisions. This will work just fine. All right, so we now indeed have our column as just one piece of geometry. Really useful. So what's next is we are going to make some procedural UVs. So for this particular thing, we will not do something super amazing. We'll just do UV projects, press Shift Enter, and indeed we will just select the cylindrical because our column is a cylinder. However, it might be not the best solution for now, because what we want to do now is to have some UVs on top and on the bottom, because as you can see, the cylindrical projection kind of ignores the top face and the bottom face. On the bottom, maybe it's not as important because it will stand on the ground, so who cares if it does have UVs or not. But the top one, it better have something, because like say if you jump on top and there is no UVs, they'll look really, really weird, right? So what we want to do is to have a way to actually procedurally UV the top and the bottom and all of the other faces that are not being correctly UV'd by this cylindrical projection. So let's do another group and select everything by normals, everything that looks just on top. It's gonna be this face and this face. Look at the sky. Let's do another group. And let's call look at the sky inverted, for example. And let's do the direction -1, 0, spread angle 0. Okay, so it will actually take into consideration this face and this face. Okay, so now we want to do UVP, again, UV project, but for the group will be look at the sky and look at the sky inverted. So these two, and as you can see, the plane should be, if I'm not mistaken, ZX plane. Yep, here we go. Initialize, and you will immediately see that we have UVs everywhere, and it will work just fine. If we press spacebar 5, you will see that indeed it looks how we want it. All right, so final thing, we can do procedural UV layout. However, in this case, you will see that our UV layout actually started to move elements around. For example, this ring, the top elements, they now take much less space in the UVs. However, I don't think we want this, because this is just the elements, architectural element that will be somewhere in the background. We don't need to actually lay out this UV in this case. So I think the UV project will do just fine, right? It doesn't really matter that the UVs overlap, because we will just slap one texture, one material, and it will be like whatever. Somewhere in the background doesn't really matter. So again, we can do the UV layout. We can do the UV layout not. It does not really matter. Before that, I think we can do the poly bevel. Select everything that is 90 degrees. Deselect the group. Ignore flat edges. Everything almost 90 or 90 will be selected. And those are just these two edge loops. And of course, increase the distance ever so slightly. This might be a little too small. And let's see how it looks if we make the normals. Again, pretty much my favorite, weighted normals. Let's see how it looks. It should be looking fine. And yep, everything looks relatively correct. I think in the game it will look correct as well. Final thing that we need to do, since we are using it inside of game engine, it does not work well with the n-gons like this one. Especially it will not work well with the n-gon like this one. Let me just showcase that this is one polygon. This is the huge n-gon with God knows how many different vertices. So we need to triangulate everything so it kind of looks correct in the game engine, and this is done really easily by tap, divide, shift, enter, and there we go. Whoops. So here's the thing. If you do something over the viewport, it will assume that you want to select something by hand. However, if you do it in the context of our nodes, it will not assume you want to select something. So if you want to select everything, do it here. If you want to select something by hand, do it over the viewport. It might be a little bit confusing because, as you might have seen, it automatically selected thing. We didn't want to select anything. You'll be like, what's going on? So the point is, if you want to drop a node that does not, take into consideration anything in the viewport, drop it where the nodes are. Okay, so everything is divided, everything has been normalized, everything is fine. So FBX wrap output. However, we are indeed creating an Houdini Digital Asset, and we do not want just to make the classic raw export, right? As we have done previously. What we want to do is select all of our nodes, press this button, subnet, or indeed Shift C, right? You will see that it has been collapsed into subnet. If we go inside, the result is the same. The only difference is that here is the output. However, here it's just one node. So we can use that to create a Houdini digital asset. How to do that? Right click, digital asset, create new, and let's call it column UE5, create. Of course, you can name it however you want. Click accept, And as you can see, we have this column UE5. If we right click, go to our digital asset, it actually is not named as such because we need to right click, type properties, basic, and here we can label it column UE5 tester 1, for example. Apply, accept, and now if we do the Houdini Digital Asset, here it is, column UE5 test 01, and it's the same thing. If we double click, go inside, you will see that here's our network. So how do we make it so that we have actual controls that we can use inside of game engine? In our case, we go to type properties, go into the parameters, jump inside, and of course we can now drag and drop things and they will automatically populate. So radius scale, let's say column radius scale. Next up, what I want to do is group range. No, actually, I want the amounts of columns. Let's call it division amounts. Click apply, accept. And if we go outside, you will see that we have both column radius scale and division amount. Of course, it can become a little bit wacky because we have the polybevels. So as you can see, our last polybevel gives us a little bit of a problem because it starts to take into the consideration if we have too many elements of our divisions or the radius is too small, these inside extrusions parts will actually be 90 degrees as well. So this causes somewhat trouble, right? So we need to fix that. What we want to do is go to our polybevel, and remember we talked about these collisions and limits and whatnot, and the ways to fix the problems with bevels. Slides on ring edges we get from auto to always, and the problem fixed. All right, so again back to output, check it. All right, this looks much better. To save the result of our tweaks and to actually save the result of the digital asset, all you gotta do is right click, save node type, and now we can get back to our Unreal Engine and start playing with our new column there. Let's do that. Okay, so I'm now in the Unreal Engine. Let's delete this, delete that, and I have created a new folder called HDAs, and here all we gotta do is, in my case, the Houdini documents is in the documents, Houdini 19.5, and here I go to OTLs, and you'll see that we have the column UE5 1.0. All I gotta do, drag and drop, drag and drop. It will take a couple of seconds to think. And here we go, it's our column. All right, so we can actually go and preview it with the materials. In my case, I'm gonna do the polished marble, and you will see, if we press F, that indeed it does look the way we want. And of course, if we go back to this, so be careful, because in the static mesh component, we can switch the material. However, if we want to tweak our geometry, we go to this top level and we can start tweaking. So let's do the column radius scale 0.9. Here it is, automatically on the fly. Division amount 12. You name it, you got it. So that's really great. That's like almost perfect. So what's left is that we can actually just press the bake button. And of course, if we press the bake button, you will see that there will be the white column, and you're like, wait a second, what's going on? In fact, we have two columns now, one of which is the bake one, and the other one is the HDA. So if I select this, you'll see that indeed it is the HDA. And if you want to bake and not get confused what's going on, remove the HDA output after bake, enable this, bake, and the HDA itself has been deleted. and all we are left with is our geometry. So go back, polished. Here we go. Here we are. This is our column. Right-click, nanites. We can enable the nanites. It works perfectly as well. So if we preview real time, if we preview, go to the nanites visualization, and for example, go to triangles, move away, move closer, everything works. The point is everything works fine with it, nanite as well. So here we are. Of course, you can go back to our column, UE5, and for example, let's actually tweak the amount of this bevel. Here it is, the distance, right? So again, we go to our type properties. We can drag and drop this distance offset, right? And as you can see, it's 0.021. So for example, the range will be from 0 to, let's say, 0.05. Apply, accept. Actual correction. I said that we need to change the distance scale. However, accidentally, I wrote it inside of column radius. It should be 0 to 1. However, the distance itself should be from 0 to 0.005. Again, column radius scale from 0 to 1. Otherwise, it will be bugging out. And you will see that if we now save our digital assets, we go to Unreal Engine. Whoops. Where is it? HDA. We drag and drop it here. For example, if you already had the instance of it, you could just press rebuild and you will see we indeed have the distance. They will be tweaked on the fly as well. 0.001. You'll see that it's a little bit more pronounced here. So this is the basics of how you can create a lot of things on the fly inside of Unreal Engine or any other application. And this is how you utilize the Houdini engine and Houdini Digital Assets, and of course procedural modeling inside of Houdini in any other application. Hopefully you enjoyed this lesson, and if you're interested in learning more, naturally subscribe to the channel. If you have suggestions and ideas, don't hesitate to leave them in the comments. I try to read the comments, and of course, if you like the video, press like. If you didn't maybe like something about this video, you can comment why you didn't enjoy it. Hopefully you did as much as I enjoyed creating it, and I am wishing you a nice day. Hope to see you in the next one, and bye-bye.